Hi students, in the last video we have discussed like alternative life cycle models, right? What are alternative life cycle model? Why actually the alternative life cycle models needed and all, right? Since due to the shortcomings or drawback of traditional waterfall model or V model, we need alternate life cycle models, right? So in this one we discussed waterfall spin-offs as well as specification based models and all, right? And under the specification based model we have two main model like rapid prototyping life cycle, and another one is executable specification. This model we have already discussed, right? So in this video we're going to know the system called SATM system, or simple, you know, a simple automated teller machine model, right? So if people can see here, uh, in the last class, sorry, in the first model also we have seen this one, right? Only the introduction model only we have seen, but in this model, we're going to discuss this thing with respect to analysis, structural analysis and all, right? So usually it has 15 screen, right? 15 screen, like from screen 1 to screen 15. This is a you know screens of for SATM. So it contains welcome, enter your personal identification number. The personal identification number is incorrect, invalid identification, select transaction type, under that one balance deposit withdrawal. So these are all actually uh, screens which available on SATM, right? This SATM is actually greatly reduced system. So commercial ones have hundreds of screens and time modes actually, but this one, sketch of this SATM terminal, is actually that terminal which has display screen, functional buttons B1, B2, B3, like this one. So B1, B2, B3. So in the exam actually they will ask for SATM system. Okay, you need to write this diagram as well as the first one. Okay, so if you are not remember, don't worry about that one. Write 15 screen, and whenever possible, whatever you have remember, that part only you can write here, but this is compulsory, it's easy to remember, right? Here we have one welcome screen is there. This is actually that terminal. Under this terminal we have a button, right? So functional buttons B1, B2, B3, and digit keypad with cancel key, right? Cancel key is there, and 1 2 3 4 digit keypad is there. Receipt ID card is there. Cash dispensing door is there, and deposit envelope door is there. It is actually a SATM terminal. Okay, so they will ask explain SATM system with structural analysis approach. Okay, why we need to study this means, here the main concept we are going to uh, you know we are going to study is actually what the system, the different approaches of testing, right? Like unit testing, integration testing, system testing, acceptance testing, regression testing and all. So here also, in this approach, right, in this approach we studied, right, levels of different level of testing as well as integration testings. So this is part of integration testing, SATM system. So how do you actually perform the integration testing or different level of testing by giving the SATM system as an example. That's why it's very important to study this system, right? This structural analysis approach is this technique is based on three complementary model actually. Okay, one is functional model, uh, second one is data model, and third one is control model. Okay, the functional model we use data flow diagram for the functional model. For data model we use ER model, and for control model we use finite state machines. Okay, these three things we should remember. We have some example here, the context diagram of this SATM. This also need to exercise this thing. So a simple ATM system is there. Under that one we have in different parts, like central bank. First thing is central bank, which is actually bidirectional approach. It will expect the pin, and they will personal identification number, and then pan, it will expect the pan, and B terminal screen, C terminal doors, D terminal slots, and E terminal keys. Okay, different approaches are there here. So this one is level 1 data flow diagram. So different data flow diagram is there, like 1.1 device sense and control, 1.2 central bank common communication. In this way we have different parts, right? So while writing about this one, we have one tool called deft case tool. Okay, deft case tool from CBS company. Okay, this deft case tool, elements of the functional decomposition are identified with the number, like here 1.4 for managed session, right? For example, here you see 1.4, here we have a managed session. These elements of functional decomposition are actually identified with this number. So in the last video we have observed one concept like functional decomposition as well as composition. So in this approach, in the functional decomposition approach, with the line number 1.4, with the number 1.4, so we are actually identify this functional decomposition. Also some arrows are there, like open and filled arrows. Open means compound flows, filled means simple flow. For example, here example for compound flow screen, you can see screen 1 is welcome, right? In this example, compound flow as well as simple flow here. So in this approach, this compound flow screen 1 is these are all example for compound flow approach, right? Screen 2, enter pin 1 2 3 4 5, these are all example for compound flow screen. So see here also one is compound flow, here it is the filled approach, what we called, right? Filled is simple flow, whereas open is compound flow. So filled is simpler flow, right? Slot command or filled approach, where this one slot status, door status and all open flow. Okay, this point which is remember there. Okay, this entity relationship diagram with respect to that approach. Here also it is a concept of database. People might know, right? The customer has account, the customer session transaction, and also customer uses terminal. So here the transaction occurs terminal, right? These are all some bidirectional approaches there, right? So this is entity relationship diagram with the customer. You can see here customer has a relationship with the account, is a hash relationship with the customer has account, and also customer and terminal, coming to the customer to terminal, it has users relationship, customer uses terminal, and also the transaction occurs terminal. So transaction actually occurs at the terminal. So these are all the approaches. So this is actually not a complete diagram, incomplete ER diagram, media data structure, customer account terminal transaction. Here we have seen the single arrowhead as well as double arrowhead, right? What exactly is the single as well as the double arrowhead? The singularity or the plurality of the relationship. Many transactions may occur at the terminal, but one transaction can never occur at multiple terminals. See here, one customer may have several accounts and may conduct none of several transactions. This is for many relationship. For example, you can see here, customer may have several accounts, right? Customer, see the double arrow here, right? See the double arrow here. The customer may have several accounts, right? And also that terminal may contain actually occurs at many transactions. In terminal, many transactions can occur, but the transaction can only occur at a only one terminal. That's why it has a single head. But rest of them, these are all double R8. These are all double R8. Okay. So terminal also has a mini customer. Customer can use the mini terminals. Double R8. We have also double R8. We have only single R8 here. Okay. So this is actually the example of ER diagram, interrelationship diagram. You can refer here. First one, we see first one is data flow diagram, second one is interrelationship diagram, third one is finite state machine. These are all a way of describing the ATM machine. Right? Data flow and ER contain information that are primarily structural. For testing, we need behavior. Okay, to execute the testing thing, we need behavior approach of the system. That's why control model represents the point at which structure and behavior intersect. That's why finite state machine can be hierarchically decomposed here. In here we mentioned, right, in this slide, for if you want to follow the functional model, we use data flow diagram. For data model we use ER diagram. For control model we actually use finite state machine. Okay, in the structural approach, right? So in this finite state machine, you can see here, this is actually a finite state machine. Different states are there, like idle state, avoid pin, avoid transaction selection, balance, deposit, withdraw, close session, and all, right? So each has a relationship, like avoid pin can go for idle state again, and from close session we can again go for avoid section. From close section you can again go for idle section, and from avoid transaction selection you have three approach like P3, P1, P2. So if you press the B3 button, it will display balance, B1 button deposit, P2 button withdraw, right? So in this way it's actually finite state machine, right? And cancel, yes, no, pin OK, display screen are actually what button you can press and all, that result of that button. Okay, this is a finite state machine of SATM. This one is some pin entry. What will happen if you enter the pin 10 enter? This is not an important thing, but this diagram is important. You can this, not this one. This is important diagram. You can remember by practicing this one. It's not important. Okay. So in both figures actually state transaction are called either by events at the ATM terminal, like keystroke and all, I by data conditions such as recognition that a pin is correct or not. When transaction occurs, a corresponding action may also occur. Okay, these are all some examples. So functional decomposition, we also talking about functional decomposition, right? For a SATM system, it's decomposed into different systems like device sense control, central bank communication, terminal sense, management and all. And also under device sense control, we have two approach: door sense as well as slot sense. In terminal sense and control also we have two things: screen driver and key sensor and all. Okay. For manage agent, we have manage agent. How do you go to manage agent? Validate card, validate pin, manage transaction, close agent, and under the validate pin you have get digit. Okay, in this way we are going to decompose the functions. This is one of the partial function decomposition, but here we miss the fact that some functional are used in more than one place, right? Because we use more than one place here. But how to overcome this thing? Another approach is there, call graph approach. That is we are going to use in the upcoming slates. Okay. Here the functional decomposition carried further in outline form. The numbering scheme preserves the levels of components. You can see here, the numbering scheme actually preserves the component level, right? Like SATM, under that 1.1, 1.111, 1.111 for SATM is first thing. Under 1.1, 1.2 you can see here device sense control. For 1.1 device sense and control is there. For 1.2 central bank communication is there. You can see here device sense control 1.1, 1.2 central bank communication 1.3, terminal session 1.4, magnet session 1.1. 1.1.1 is towards sense control, 1.1.2 is large sense control. So in this way we're going to decompose the thing. It's very easy, right? So under this one whatever comes you can just try it, right? This is some program which I actually written in some language, so to illustrate this program diagram. Okay, it's not an just read this one. The program is rating and is not an important part of your program. Just write the structural analysis of ATM, SATM. That is the important thing. Okay, so here also after reading this one, the another important thing is separating integration and system testing. It is actually another important thing. So we are almost a position to make a clear distinction between integration and system testing, right? After writing the system testing and integration testing, you can ask, generally you can say that system testing is nothing but the complete after integration of all parts we are going to make a testing, that is system testing. So integration is nothing but we are going to take a unit, different models, we will combine the model and we will integrate the model and we will conduct the test. That is called integration testing, right? So we need this distinction to avoid gaps and redundancies across levels of testing, to clarify appropriate goals for these levels, and to understand how to identify test cases at different levels, right? We need a different distinction for that one, so to avoid the gaps and all, right? This whole discussion is facilitated by a concept essential to all levels of testing, that is the notion of thread. Thread, people know, right? Thread is nothing but a basic unit of execution. A thread is a construct that refers to execution time behavior. When we test a system, we use test cases to select the threads. We can speak of levels of threads. System threads describe system level behavior, integration threads correspond to integration level behavior, and unit threads correspond to unit level behavior, right? So instead of talking about different process, here we are actually talking about different levels of thread. Here we directly come one step closer to the thread level. Okay, thread level in the sense basic unit of execution level, right? We shall see that threads are most often recognized in terms of the way systems are described and developed, right? If you want to execute test cases, you should know the basic thing. That is the point. For example, we might think of a thread as a path through a finite state machine description of a system, or we might think of a thread as something that is determined by data construct and sequence of port levels input and all. So you can think, for thread and all, maybe it's a complete process, maybe it's part of the process, right? We could also think of a thread as sequence of source statement or a sequence of machine instruction, right? Even one statement can be a thread or a source of, or a sequence of machine instruction can also be form threads, right? The main point here is threads are generic concepts and they exist independently of how a system is described and developed, right? It's a generic thing. So how the system is actually described and developed, it's actually independent from the threads, right? That is something, some related concept regarding threads and all. There are two insights will come in this concept, right? One is related to structural insight, another one is related to behavioral insights. What exactly the structural insights is? So integration testing is at more detailed level than system testing, right? Compared to the system testing, integration testing actually has more detailed level. One common view is that integration testing is concerned with the interfaces among the units, right? If you combine different units, means you should need a interface. Through the interface, you're going to combine those models. One possibility is to fall back on the symmetries in the waterfall lifecycle model and say that integration testing is concerned with preliminary design information, while system testing is at the level of requirement specification. So based on waterfall model, so we can say that this integration testing, okay, the integration testing is concerned with preliminary design information whereas the system testing is concerned with requirement specification. Of course, you people should know, right? Requirement specification is the first step of development. After that one, preliminary design will come. So the system testing is deals with requirement specification, where integration test is deals with preliminary design. This point you should remember while writing regarding structural insights. Okay. Of course, this is a popular academic view, but it begs an important question. How do you discriminate between specification and preliminary design? How do you actually differentiate between specification as well as preliminary design? Right? In some system, we don't have any preliminary design at all. So in this case, what you are going to do? This kind of question we need to answer. So if you actually coming to this point, this is not a generic general point. Actually, some people will say this one, some people are not actually okay with this thing. Okay, the answer to this is that what versus how dichotomy will come. The requirement specification defines what to do, whereas the preliminary design describes how to do. Okay, if they ask, if anybody who are not satisfied this concept of requirement specification, actually system testing deals with requirement specification, whereas integration testing deals with preliminary design. How do you do that? How do you say that? You can say that uh, it can be answered by what and how dichotomy. What in the sense, requirement specifications, says defines what to do, whereas preliminary design specifies how to do that thing. Okay. This is another model, like the model used in developing process provides some clues. Okay, if we follow a definition of the SATM system, we could first postulate that system testing should make sure that all 15 display screen have been generated. Okay, the entity relationship model also helps. The one-to-one and one-to-many relationship help us understanding how testing must be done. Okay, these are all uh, you know proof that what we actually explain regarding system testing, integration testing should actually what is the difference between these two. These are actually proofs and all, right? So control for the entity relationship model also help, the control model also helps, as well as function model also help in this regards. Okay, how they are well, the control model, hierarchy of finite state machine is the most helpful here. You can postulate system test cases in terms of paths through the finite state machine. Doing this yields a system level along the structures testing. This way will help, where function model help by move in the direction of levels up, because both express a functional decomposition. Okay. Next, uh, they will actually tells that the instant following threads are clearly at the system level, like insertion of invalid card, insertion of valid card, and all. These are all related to system level thread. Okay. Coming to the behavioral insights, think about a system in terms of its port boundary, which is the location of a system level inputs and outputs. Every system has a port boundary, right? It's coming to the how behavioral insights actually related to this one. System has a port boundary. The port boundary of the SATM system includes digit keypad. Okay, the function buttons, the screen, the deposit, the withdraw doors, the card and receipt lots are there in that one. Okay, each of these devices can be thought of as a port, and events occur at system ports. Right, the port input and output events are visible to the customer, and customer very often understands system behavior in terms of sequence of port events. So behavior insights is always related to system behavior, how the system actually going to behave. So in this regard, the system is nothing but the ATM. Okay, simple ATM. So here they consider the port approach here. Okay, the port is the port boundary is the this actually a location for system level inputs as well as outputs. So person who is going to the ATM, he will give some input, he will get some output, so through some ports. So they have considered the interface as a port. So every system has a port boundary, right? Every system has a port boundary. In the same way for SATM also port boundary. What are the port boundary for SATM system? Like digit keypad, the functional buttons, the screen, the deposit and withdrawal doors, and card and receipts, because these are all the parts where the person interacts. Okay, interacts and he can know the behavior of a system. Right, each of these devices can be thought of as a port, and events occur at system ports, of course. Right, these can actually occur at the system port. This port input and output events are visible to the customer, right? Of course, he is the customer who actually went to ATM. He is he will these activities will be visible to the customers, and the customer often understand the system behavior in terms of sequence of port events. Okay, so if you want to know the system behavior, in this case SATM system behavior, he only knows through the port events only, port activities only, right? Even this we manage that system port events are primitive of the system test cases. That is, a system case test case or equivalently a system thread is expressed as an interleaved sequence of port inputs and outputs event. Okay, that fits for understanding of a test case in which we specify preconditions, input, outputs, and post condition. Of course, with this mandate, we can always recognize a level violation if a test case ever requires an input that is not visible at the port boundary. The test case cannot be a system level test case. Okay, if you are not be able to see the port events which actually related to testing and all, to conduct the to execute the test cases, if it is not visible at the port boundary, then you can clearly say that it's not a system level test case. Notice that this is clear, recognizable, and enforceable, right? So whatever the event which are actually visible to the port boundary, port events, for that event only you can execute the test cases. Okay, that is the main idea of this behavior insight. So for the next video, so I'm going to explain the later part of integration testing. Integration testing, actually we explained what exactly integration testing and all the basic thing, but the advanced version of integration testing is also there. We're going to see what exactly the components of integration testing and all in the next video. Okay, so thank you guys for watching.